Hello, my name is Mohammed Sulaiman Khan, and today I'm going to talk on the topic of implementation of Stateful Firewall using RYU controller. The agenda for today is what is software-defined networking, what is the need of SDN and firewall, what motivated us in selecting this topic, what is our research proposal, how are we going to evaluate it, and finally a conclusion. So let us understand what is software-defined networking. In simple terms, software-defined networking is an emerging network architecture that provides unprecedented programmability, automation, and network control by decoupling the control plane and the data plane. In SDN architecture, network intelligence and the state are logically centralized and the underlying network infrastructure for network application. The diagram below then tells us about the software-defined networking architecture, which is categorized into three layers: management layer, control plane, and forwarding plane. The control plane acts as the SDN controller which forwards the traffic that is generated from the data plane towards the management layer. The data plane can be defined as the traffic generated by the user to the user or to the server. Okay. So, what is the need of SDN and firewall? The security of the network is important. One of the methods to provide the security protection is to use a firewall. The firewall protects the security of the internal network from the attack of the external network. It filters the incoming and outgoing traffic or packet using various defined rules. The SDN switch can be enabled to use the firewall function. This can be done by adding the matching rules and action rules to the flow table of SDN switch. So, what motivated us in selecting this topic? Well, first we need to understand the differences between traditional firewall versus the SDN based firewall. This traditional firewall have a distributed control plane, whereas in SDN it is more centralized control plane which manages the data flow of traffic. Moreover, the traditional firewall requires a lot of manual configuration and changing, which is a very overhead for the network administrator. Whereas in SDN it is more software based, which makes it easier in configuration. So there are two types of firewall: stateless firewall and stateful firewall. Stateless firewall has been researched on the SDN for the past years. However, stateful firewall is still undergoing the research in the SDN. Okay, because we know that a stateless firewall are known to be more secure than stateless firewall. This is due to the fact that administrator will no longer need to write specific rules to allow returning traffic. This closes the security hole opened by returning rules, which can be used by an attacker to launch denial of service attack. Also, the rules in stateful firewall will be shortened since single rule will provide enough information about a flaw as opposed to two rules in the corresponding stateless firewalls. So let us talk about the related work we have done till so far. Okay. Well, on reading this paper, implementation of stateful firewall using POX controller, the author talks about how they implemented the stateful firewall using the POX controller. As they say, the controller is easy to use, and further it uses Python as the programming language. The author then creates a Python dictionary for maintaining the connection tracking information, which will initially be relevant in my research method. As the author explains about stateless firewall, the drawback of stateless firewall is that it assumes all the packets that are transmitted through the firewall are trustworthy, which means that an attack can force the route of the packet towards yourself and be able to gain important credentials. The other possible loophole is that it does not allow it allows all the synchronization and acknowledgement message to pass through the firewall even if there's no sync packet that has passed through the firewall earlier, which doesn't rule in any TCP three-way handshake. So basically the whole process is carried out by using a POX controller, which when compared to my method, we see that POX controller only supports the OpenFlow version 1.0. which which doesn't have features like grouping, VLAN support, TCP, flag support, and even IPv6, which is needed in today's most important networking environment due to the IPv4 getting exhausted. In the other paper, the author actually uses the open low version 1.5, which is actually the best till now because it supports all the various functionalities like TCP flag, egress, ingress filtering, etc. The author describes about the stateful firewall which checks the TCP connection and permits only those TCP connections that have been initiated from the client of the internal network, which means that when the TCP connection session is finished, the stateful firewall does not allow the traffic to pass from the outside network to the inside network and vice versa. Problem found in the above work is that the technique lack performance evaluation and doesn't support today's attack techniques. So, so the question arises, can we overcome with the overhead performance and scalability problem? Yes, we can overcome with the problem by using RYU controller in the implementation of stateful firewall. So how are we going to carry out this method? We will be controlling from the below diagram. We understand that there we will be using a RYU controller and open vSwitch which will be integrated in between, and there will be three hosts generated. The host one All the hosts will have an IP and the host tree will act as a client. Finally, the RYU controller and OpenFlow switch is used to test the deployment. We will use a packet builder tool called Ostinato, which will be used to generate fake traffic, which will help us in identifying whether the Wireshark detects the fake packets or the firewall blocks it or not. Finally, I would like to conclude by saying that we will try to develop the design which has less performance overhead than the current technique. And finally, the proposed controller supports all the functionalities as compared to the previous published methods. Thank you.